All right, this is pre-algebra lesson 8.2, equations with two variables. I'm not going to do this lesson the way they want me to. We'll get started in this tomorrow more. I just want to show you a few things. One, okay, there's lots of different types of equations, but here's the deal. When you have an equation with two variables like y equals 3x plus 4, okay, first of all, you're going to want to get used to looking at that guy right there. That guy is a very standard-looking linear equation. That is a linear equation. What do you think linear equation means? What does the word linear mean? What does it sound like? A line, right? It's a linear equation because this thing is actually a line. Okay, that answer, the solution to this equation right here is a line. There is not one answer to this. There's an infinite number of answers. Okay, it's one of those things that I could say, well, if y is this, then what's x? If y is this, what's x? If y is this, no matter what I choose for y, there's going to be an x answer. Does that make sense? That's why there's an infinite number of answers. Somewhere on the deal, here's our coordinate plane. It's going to look something like this, right? And it goes forever in each direction. So there's an infinite number of solutions, right? The answer is a line. Okay, does that make sense? So there's not one answer. Now, if I was to say something like, well, if y was, 10, then what is x? Or if x is 10, what is y? There will be one answer, right? Mm-hmm. But there's an infinite number of answers. So anyway, let's just say, I'll get one really quick one. Let's just say that x, if I say, okay, if x equals, we'll say 2. If x is 2, you tell me what y is right now, okay? You figure that out right now. All right, so you guys say the answer is 10. So here's the deal. You're going to plug in x is 2. Where x, instead of x, you're going to put the number 2, right? So you're going to go y equals 3 times 2 plus 4. Well, what is 3 times 2? 6. 6 plus 4 is 10. Y is 10. So when x is 2, so our line is going to be somewhere here. When x is 2, y is 10. So it's going to be somewhere like up here. Does that make sense? That means that dot right there, this dot right here, is somewhere on the line. Does that make sense? That's going to be part of the line. That's not the solution to this equation. That's just part of the solution. You actually need to make 2 points, find 2 points. If you find 2 points, then you can connect the dots and just extend them forever, and now you have the line. Does that make sense? Can you tell me where the line is based on one dot? No. I mean, it could be here. It could be here. It could be here. You can't tell. But if you get 2 points, now you have the line. Make sense? Okay. So then let's just say let's do this. Let's make x be negative 2. Okay. If x was negative 2, nobody says it out loud. I want you to write it down. If x was negative 2, what is y? Instead of writing 3x plus 4, what am I going to put? 3 times negative 2 plus 4, right? Does that make sense? Yep. So what is 3 times negative 2? Negative 6. What's negative 6 plus 4? Negative 2. You have to know your positive and negatives. You don't have to know how to add and subtract negatives, right? If this is negative 6 plus 4 is a negative 2. So that makes when x is negative 2, y is negative 2. So that is right here. Does that make sense? That's where that point is. So then you would take your ruler and you would draw your line right here, and there's our line. There is the solution to this equation. Make sense? Okay. That's the gist of it.
Now you say
the answer is a line, right? Because I could change this to, I said, well, what if x is 100? Right? If x is 100, well, then where's y going to be? Well, it's going to be but guess what? It's going to be somewhere on this line. Does that make sense? Somewhere that answer is going to be on the line. Make sense? Okay. One thing you can do, like I was showing you there, we'll do that one again. Y equals 3x plus 4. One way of graphing a linear equation. Okay, here's our equation, right? And we already know by looking at this, there's an x and a y, right? And it's written y equals something, right? It's y equals something x plus something. We'll get to the slope-intercept form next time. That's why I really almost don't do this lesson. But this is a line. We know the answer to this is a line. Okay, this is a linear equation. And we'll talk about linear equations next time. Okay. What you're going to do is this. There's how many variables?
2.
2. So there's an x and a y. So what you're going to do is you're going to create yourself a table. You literally create a table. And you make it be an x and a y, just like you've done many times. Right? You're going to make a table. X is on the left, y is on the right. And these are going to be coordinates. Do you agree? That's going to be a coordinate. That's going to be a coordinate, right? So what are the coordinates? What do I do to make these coordinates? What do I do to make this into something that I can, well, here, what do you mean solve it? I have to have points on my graph. So right, here's my coordinate plane, right? There's my coordinate plane. And I have to have somewhere to put something. So what do I do? You need to start choosing numbers for x. You literally choose numbers for x. Here's the rule. You ready for the rule? As a general rule, you're going to need to choose numbers for x. There is an actual pattern of numbers that this is kind of like the default number pattern you're going to choose. And that is you choose -2, -1, 0, 1, and 2. Those are the 5 numbers you choose. Okay? If you're only going to choose 3 numbers, if you only choose 3 numbers, which you can do, then you choose -2, 0, and 2. Okay, you choose those numbers. You pick it. Remember, what is this thing again?
Should we write this
What is this thing again?
in a line?
It's a line. It's a line. So it's somewhere on the right. There's a line somewhere. It could be here, it could be here. Right? There's a line. It's a line. Agreed?
Yep.
And so whatever I choose for x, is there going to be a y? Yeah, it's a line, right? I mean, there's going to be a line somewhere. So whatever I choose for x here, there's going to be a y. You see what I'm talking about? Whatever I choose for x, there's a y. What if I choose x to be a negative? Well, there it is. Well, there's a y. Do you all see what I'm saying? There's going to be a y. So then you pick whatever numbers you want. You just don't want to pick 100 because all of a sudden, do you really want to graph x equals 100?
No.
No. So you want to keep it near 0, right? You want to keep it near 0. And 0 is always when you choose 2. Let's solve it now. We take the -2. Okay, so that means we're going to plug -2 in. Didn't we already do that one? When x is -2, what was y?
-2.
Was -2. When let's make x be 0. Y equals 3 times 0, which is?
4.
3 times 0 is 4.
Oh, 0.
Follow my thought here, right? We're going to make x be 0 now. Look, are you understanding this? We're going to make x be 0. Why are we making x be 0? You tell me. Why are we making x be 0? Why?
So it's near the...
Right, but why? Why are we choosing 0? Because we want to.
Yeah.
Could we choose 1?
Yeah.
Could you choose 1? Could you choose 100? You could choose whatever number you want. We're just picking whatever number we want. And it will be on the line. So why do we choose 0 then? We know that we can do whatever we want, but why do we choose 0 then? Because it's the easiest one. We can, and it's the easiest number to do. Let's make x be 0. Y equals 3 times 0 plus 4. Gigi, what is y equals 3 times 0 plus 4? 4. Y equals 4, right? Because 3 times 0 is 0, plus 4 is 4. Y equals 4. So look, that means when x is 0, y is 4. We also choose the number 2. Why 2? Well, because we choose whatever we want to, and we choose 2 because it's an easy number to do. Y equals 3 times 2 plus 4. What is y equals 3 times 2 plus 4? 10. We did that one already, right? So y equals 10. So here's the deal. Graph these. -2, -2, right here. 0, 4 is right here. And 2, 10 is right here. Do you see that they all land in the line? If I had chose the number 3, where would it have ended up? Over here somewhere, right? It would have been over there somewhere. Does that make sense?
So wait, you get to pick 3 random numbers and then you have to multiply the numbers.
No. Then you plug those numbers into the equation, right? And figure out what y is. You say when x is 0, then y equals 4. Oh, hear that? That's where you write that.
Okay. Does it have to be a straight line?
It will always be straight.
Okay.
If you did it right, it will be straight. And that's why you choose 3 numbers. You always, when you do this, you don't choose 2, you choose 3. Because if you choose 2, no matter what, 2, you know, whatever 2 points you've chosen, you go, wow, I did it right because it's a straight line, right? No matter whatever 2 points you choose, is that going to create a straight line?
Yeah.
But if you do a third one, and one of them is here, and one of them is here, and one of them is here, oh, you did something wrong. You know what I'm saying? Because what should they all land? They should all land on a line. If they don't line up, then you did something wrong. That's why you always choose at least 3. If you want to be really sure, you choose 5. And all 5 will land on the line. If they don't land on the line, you did something wrong. Yes?
So, do you want us to do 3 or 5?
3 is fine. One last thing here. Okay, one last thing. Remember, we've talked about this yesterday, to make something a function. So what if I, here's my deal. What if I have y equals 2? How do you graph y equals 2? We've done this before, I think. How do you graph y equals 2? So here's the y right here. We'll say that's the point, right? So is it like this? Does it go up and down like this? Is that where that goes? No. How does y equal 2? Show me with your arm how you would write down y equals 2. Is it like this? Is that how I would do y equals 2? How do you do y equals 2?
You graph it from 0?
Nope.
No.
Y equals 2. Listen, I have a question again. Let's just say, let's do this. Forget the y-axis. Do you agree here's a number line? Do you agree that that's the number line you've had since kindergarten?
Yeah.
Right? 0, 1, 2, -1, -2. So here, if I said graph for me x equals 2, you would use to put a line, you would just put a dot there, right?
Yep.
But that would be like, you'd say that's x equals 2. Agree? Do you agree that's x equals 2? Technically, that's not true. Well, it is true, but if you're going to graph it in a coordinate plane, you would draw it like this. That is x equals 2. Okay? You all understand that the number line you've had forever is the same exact thing, except now that you're in 6th grade or 7th grade, we just have added the y-axis, right? We've added the y-axis, right? And so if there's 0 and there's 2, if this is x equals 2, right? How do you draw y equals 2? There's y equals 2. How do you draw that?
This way?
That is y equals 2. You have to memorize this, people. You have to learn this. Is this hard math? Is this hard arithmetic? No. You need to know that when you do y equals something, it's going to be a line like this, right? If I said, where's y equals -5? Point it out to me, please. Bradley, y equals -5. What am I going to do? If I said, graph for me y is -5, what do you do?
What?
Y equals -5. Y equals -5. How would you graph that?
Put the -5 there?
Where? Tell me exactly what to do. If I said graph this, huh?
Below the x-axis.
Right. So there will be a -5, right? Is that what I do? Is that how I do this? You draw a line. That is y equals -5. GG. How would I do y equals 10? What do I do? How do I graph y equals 10? What do you mean over there? What do you mean? Over there? Yes, you do. Use up, down, left, right. What do you do? This is called the origin, right? Where the two cross. So use that and tell me what to do.
Top right?
No. What do you do? How do you do y? Listen, Gigi, if this is y equals -5, agreed? If that's y equals -5, where do you think y equals -4 is going to be? A little bit above it, right? So where's y equals 10 going to be? And is it going to look like this?
No.
No. What's it going to look like? I'm talking to Gigi. What's it going to look like? Right. It's going to be up here, and it's going to look like this, right? Y equals looks like this, right? X equals looks like
This.
this,
So it's the
Right?
opposite.
so if I said graph y equals 4, you're going to go up here and go 1, 2, 3, 4, and there's y equals 4. Okay. If I said graph x equals 4, you're going to go 1, 2, 3, 4, and it's going to be right here. That's x equals 4. You just have to memorize that. Is that hard arithmetic? No, it's not arithmetic at all. You just have to memorize that. The y-axis, right? The y is the up and down horizontal. X is this, okay? So then now let's look at this. If I have my guy here, and I said y equals 2, I want you to tell me whether or not that's a function. Y is 2, you'd graph it and you go like this. Do you remember yesterday? Is y equals 2 a function? How do you know if something's a function?
Oh.
How do you know? How do you know? Nope. How do you know? Just by looking at it.
It doesn't have more than two different.
Now, what's the rule? My goodness gracious. Every explanation yesterday was what? If you said it's a function. Why? Why is it a function? Why isn't it a function?
The two things on
No. People, listen. Yesterday, when I said, is this a function? Whatever the question was, and it said, is that a function? What were your two options?
Yes or no.
Yes or no. And then it had to explain. What was the explanation? No matter what the answer was, what was the explanation? If it was yes, it passed the vertical line test. If it's a no, it didn't pass the vertical line test. So then is this a function?
Yes.
Why?
Because it passes the vertical.
Oh, it passes the vertical line test. Right? How do you do the vertical line test again? You take your pencil and do what?
You walk across.
Hold it up and walk it across at any point. Is there 2 points touching your pencil?
No.
It's not. So then this is a function because
It passes.
it passes the vertical line test. People, it's that simple. Anytime I ask you, is this a function? The answer is either yes, because it passed the vertical line test, or no, because it doesn't. Oh. When you're 35 years old, and somebody asks you, is this a function? Your answer is either yes or no. And then they go, well, how come? Your answer is what? It either passes or it doesn't pass the vertical line test. Y equals 2, pass the vertical line test, therefore it's a function. What about y equals 10? Is that a function?
Yes.
What about y equals negative 10?
Yes.
So y equals any of these lines that are horizontal like this, are they going to pass the vertical line test?
Yes.
Yeah. They're always going to pass the vertical line test, Jade. Right? Because at any point, the pencil, is it ever going to be on 2? Is there going to be 2 points touching the pencil when it's horizontal like this? No. So it's always going to pass, right? So if the answer is y equals something, it passes the vertical line test. It's a function. What about this? X equals 2. Where's that going to be? That's right here, right? There's x equals 2. Is x equals 2 a function?
Yes, because it passes the vertical line test.
How does it pass the vertical line test? Right when you get to right here, and you're right here, how many points are actually touching my pencil?
1.
No, an infinite number of points is touching my pencil.
Oh,
Right here, at this point, there is an infinite number of points touching my pencil. Right? Remember, is this on the line?
No.
Is this on the line?
Yes.
Oh, yeah.
Is this on the line?
Yes.
Is this on the line? Is this? They're all on the line, right? So when I come by here, oh, how many points are touching my pencil? An infinite number. Is this a function?
No.
No. It does not pass the vertical line test. As I bring my pencil over here, I'm like, lots of times it touches. Not a function. Do you understand? You understand? If I was to smash this thing down, it would like get all scrunched up, and it was not going to be, remember, it doesn't pass the hamburger test either. Anytime you see this, and we showed you this yesterday, is that a function?
Yes.
Passes the vertical line test. Is that a function?
No.
No. Why not?
Because it does not pass the
Right, when you're over here and all of a sudden you're like, oh man, it touches here and it touches up there. It's not, doesn't pass. What about this? Is that a function?
No.
No. Why doesn't it pass the vertical line test?
Because when
The part that goes straight up and down, as you come here, you're like, oh, it touched. Lots of places are touching. Right? Does that make sense? Okay. So look, here's the deal. Any of these questions that look like this, y equals, I'll give you one. Even negative x minus 2. There's 2 variables here, right? I mean, like, here's the deal. You can, do they want you to graph them? Right, you'd graph them and then you would, how do you graph them again? What do you do to graph one of these babies? What do you have to do?
Get a number.
How do you graph it? You have to create a
Oh, wait, sorry.
a table You create a table, right? You create a table, X and Y. What do you do now? Do you start picking numbers for Y?
No,
You start picking numbers for X. What are the three numbers you should choose, Gigi?
0, wait, -2, 0.
-2, 0, and 2. That's the numbers I would choose. And then you plug them in, and then whatever you get, you plug those three in. You look at it and go, is this a function? Does that make sense? Does it pass the vertical line test? Okay? All right. I'm going to let you be. I'm going to let you be. No homework.